The universe is vast beyond ordinary imagination. The Milky Way alone contains hundreds of billions of stars, and modern astronomy has revealed that planets are not rare anomalies but common companions to those stars. Thousands of exoplanets have already been detected, and statistical models suggest that billions of Earth-sized worlds may orbit within habitable zones across our galaxy. If even a small fraction of those planets host life, and if even a smaller fraction develop intelligent, technological civilizations, then the galaxy should not be silent. It should be alive with signals, artifacts, and visible signs of activity. Yet, when we look outward with our most sensitive instruments, we find nothing. No confirmed alien transmissions. No unmistakable megastructures. No evidence of galaxy-spanning empires. This tension between high probability and total silence is known as the Fermi Paradox. The paradox is not merely a question about aliens. It is a question about statistics, time, and the nature of civilization. Enrico Fermi's simple question, where is everybody, forces us to confront a profound contradiction. The galaxy is more than 13 billion years old. Human technological civilization has existed for only about a century in terms of radio communication. If another civilization had even a million-year head start, a tiny fraction of cosmic history, it could theoretically spread across a galaxy. Interstellar travel is difficult, but physics does not forbid it. Even spacecraft traveling at 10% of the speed of light could cross the Milky Way in a few million years. On cosmic timescales, that is extraordinarily brief. If intelligent life arises frequently, then the galaxy should already be thoroughly explored or colonized. Yet we see no clear evidence that anyone has visited or modified our solar system. To analyze the problem more formally, scientists often refer to the Drake equation. This equation attempts to estimate the number of active, communicative civilizations in the Milky Way. It multiplies several factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the fraction of those planets that develop life, the fraction that develop intelligence, the fraction that develop detectable technology, and finally the length of time such civilizations release detectable signals. Some of these variables are becoming better constrained by astronomy. We now know that planets are common. We know that many stars have potentially habitable zones. But the biological and sociological factors remain deeply uncertain. Does life emerge easily when conditions are right, or is it extraordinarily rare? On Earth, life appeared relatively quickly after conditions stabilized, which suggests it might not be difficult. However, complex multicellular life took billions of years to evolve. Technological intelligence required additional unlikely steps. Perhaps microbial life is widespread, but civilizations capable of radio astronomy are rare exceptions. This leads to one possible resolution. Intelligent life is simply extremely uncommon. But there is a deeper and more unsettling idea known as the Great Filter. The Great Filter hypothesis suggests that somewhere along the path from lifeless matter to galaxy-spanning civilization lies a nearly insurmountable barrier. This barrier could occur early, perhaps at the origin of life itself. If so, humanity may already have passed the most difficult stage, making us extraordinarily fortunate. Alternatively, the Great Filter could lie ahead of us. Perhaps advanced civilizations tend to destroy themselves before achieving long-term stability. Nuclear war, artificial intelligence misalignment, environmental collapse, or uncontrollable biotechnology could eliminate civilizations before they spread to the stars. In this scenario, The silence of the cosmos is not reassuring. It is a warning. It suggests that technological societies are fragile and short-lived. The average lifetime of a civilization may be so brief that overlapping with another is statistically unlikely. Even if the galaxy has hosted many intelligent species, they may have risen and fallen across different eras, never coexisting. The universe is vast not only in space, but in time. Civilizations separated by millions of years would never detect each other's signals. Another possibility is that we are underestimating the difficulty of interstellar expansion. While physics allows for travel at sublight speeds, the energy requirements are immense. Sustaining large populations across interstellar distances may be impractical. Civilizations might choose not to expand physically, focusing instead on optimizing their home systems. If so, the galaxy may contain many advanced societies that simply remain localized and quiet. There are also hypotheses suggesting that civilizations intentionally remain undetectable. The dark forest hypothesis imagines a universe as a dangerous environment where every civilization hides in silence. Broadcasting one's existence could invite destruction from unknown rivals. In a galaxy where survival is uncertain, silence becomes a rational strategy. If even one aggressive civilization exists, caution may dominate. Under this view, the silence we observe is not absence, but concealment. Others propose that we are searching in the wrong ways. Human radio transmissions have been detectable for barely a century, and even those signals weaken rapidly with distance. A civilization using more advanced communication methods, tight beam lasers, quantum communication, or technologies beyond our understanding, might be invisible to our current searches. Our instruments scan only tiny portions of the electromagnetic spectrum for limited durations across a vast sky. In cosmic terms, our search has barely begun. There's also the possibility that advanced civilizations evolve beyond physical expansion. Instead of building vast empires, they might turn inward, constructing dense computational systems or virtual realities powered by compact energy sources. Such civilizations could minimize waste heat and electromagnetic leakage, blending into cosmic background noise. If intelligence tends toward efficiency and miniaturization rather than expansion, then the dramatic megastructures imagined in science fiction may be rare. Still, some scientists have searched for indirect evidence of advanced engineering. Concepts like Dyson spheres, hypothetical structures built around stars to capture their energy, would produce distinctive infrared signatures. Surveys have looked for unusual stellar dimming or waste heat patterns that could indicate large-scale artificial constructs. So far, none have been confirmed. The absence of evidence does not prove absence, but it deepens the paradox. Another intriguing possibility is that we are early. Although the universe is billions of years old, conditions suitable for complex life may only recently have become common. Heavy elements required for rocky planets were produced gradually through stellar generations. Perhaps we are among the first technological civilizations to emerge in this region of cosmic history. If so, the silence is temporary. In billions of years, the galaxy may become far more populated. The Fermi Paradox ultimately forces us to confront uncertainty about ourselves. If intelligent life is rare, then our existence is extraordinarily precious. If civilizations commonly self-destruct, then our future depends on avoiding that fate. If the universe is filled with cautious observers, then we must decide how loudly we wish to announce our presence. The paradox does not yet have a definitive solution. It remains an open question at the intersection of astronomy, biology, sociology, and philosophy. As telescopes grow more powerful and our ability to analyze exoplanet atmospheres improves, we may eventually detect biosignatures or technosignatures. Until then, we remain in a curious position. Inhabitant of a planet orbiting an ordinary star in a typical galaxy, looking out into a vast and seemingly silent cosmos. The silence can be interpreted as loneliness or as possibility. It may reflect emptiness, rarity, caution, or timing. But whatever the answer, the Fermi Paradox reminds us that humanity stands at a pivotal moment. We are a young technological species with the capacity to explore beyond our world. Whether we remain isolated or eventually join a wider cosmic community may depend not only on what is out there, but on how long we endure. The question, where is everybody, is ultimately inseparable from another question. What kind of civilization will we choose to become? The silence of the stars may not be a verdict. It may be an invitation.